screens don't have to change. But somewhere in the process, there is encryption going on. So that was the introduction to cryptography. With that, I'm going to jump into what is the RC3 architecture. So what is the problem that we are trying to solve here? The cloud has obviously become one of the biggest things in the industry. But if you look at the data that you use, not all your data is absolutely sensitive that needs security. If you use the standard distribution, the standard curve deviation, roughly 75%, 68% of your data is going to be completely public data that would have no effect on anyone. You go another standard deviation, you're already at 90%, and you may or may not have sensitive data even 2 standard deviations away. If you look at all your data, there's some percentage of it that's extremely sensitive, human resources, credit card numbers, medical data. Now it depends, varies from industry to industry, of course. But by and large, the vast amount of data out there doesn't require industrial strength security. So why are companies spending all that money trying to protect everything? It's because of the paradigm that we have of applications and IT infrastructure. We have this paradigm. You remember how things were back in the mainframe days and the mini computer days. And when client server came along, there was so much resistance to client server because people said, well, how can you separate an application into a client part and a server part? For a lot of people, it just didn't compute. But no one thinks it's abnormal today. Same thing's going on with the cloud right now. To a lot of people, cloud is the paradigm shift. And the thing is, well, how do we do this? Many people think either data has to be all in the cloud or not in the cloud. They don't necessarily think that there is a possibility that part of the data can be in the cloud and part of it can be outside the cloud. But if you use the same kind of logic that client server used to go from monolithic applications to splitting an application into 2 to take advantage of the benefits that the client and the server offered 20 years ago, cloud technology offers you the same benefits today. So, spoke about the benefits of cloud computing. I'm not going to go over that. But what I'm seeing at least is that legislation around data security is getting increasingly stringent. The cost of dealing with the consequences of a breach are very, very high. TJX and Heartland Payment Systems. TJX is the parent company of TJ Maxx stores, so you know them. They breached 45 million credit card numbers a few years ago, despite the fact that they were encrypting in the database. The flaw was in the implementation because the database technology they were using stored the key and the encrypted data in the same database. So if you had login access to the database, you had access to the key. So
and let me guess, the login to the database was like on the app server or something, right?
I don't know the details too much, but what I do know...
It was under the doormat.
It's like stored procedures, right? You have it somewhere in your app. The apps hard codes the key usually. Right.
But what I do know is how much they had to pay to settle the lawsuits and the FTC judgment against them. They paid $115 million for that one single breach. Heartland Payment Systems is a payment processor. They're not as visible as TJX or TJ Maxx, but they apparently process credit card transactions for 100 million small businesses. You know, barbershops, restaurants, ice cream parlors. You go in and you swipe your card. Well, many of them funnel through Heartland Payment Systems. They were certified secure by their auditor 3 years in a row. PCI DSS mandatory. It's mandatory that you have to prove you are using encryption and robust key management procedures. They passed 3 years in a row, and then out of the blue, they said they were breached. They didn't say how, and they don't say how many credit cards, but once again, what's on public record is how much they paid to settle the lawsuits and the fines against HPS. $120 million. RockU is a tiny little company right here in the valley. They're like a social networking company for teenagers. 32 million user accounts. Apparently they were storing the passwords unencrypted in their database. Hackers got into the database and compromised the passwords. Now they weren't storing credit card numbers or anything, just user ID passwords. But you know how users are. If they're using a password in one place, more than likely they're using the same password in other places. One individual filed a lawsuit against RockU. Case went to court, and the court just came out with a judgment last week. They awarded this one individual $2,000 for the damage that was done to them for the breach. The lawyers, on the other hand, got $290,000, the plaintiff's lawyers. But here's the worst part. RockU claims that they don't have the money to pay the lawyers, so I have no idea what's going to happen to them. But from a legal point of view, I understand that this judgment has established a precedent. And it opens the door for anybody to use that precedent to now file claims against companies. And if the damage is of the order of $2,000 an individual, you can just do the math, right? I don't know if people are going after Sony PlayStation, for example, or any of those companies, but those are the kinds of damages that can shut a company down. And some companies did get shut down a few years ago because they couldn't deal with the consequences of credit card breaches. So, what is regulatory compliant cloud computing? So, it's our term for a concept where we believe business transactions can span across two zones. One is what we call a regulated zone, where it is completely controlled and tightly regulated in accordance with the principles and policies and requirements of industry standard regulations like PCI DSS or government regulations like HIPAA, high-tech. And the other zone is the public zone, the cloud zone, where the data, if it were completely visible to the entire internet, it wouldn't affect anyone. Because there are no identifiers, there are no consequences. Maybe some embarrassment, but the idea is, the premise is that the architecture presupposes that the cloud cannot be trusted and that the cloud is going to get compromised. So what must you do to protect yourself and your customers and your constituents? Make sure that the sensitive data is never in the cloud, or if it's in the cloud, it's already protected before going in there. That essentially mitigates your risks. And what I'm going to be doing is describing this in a little bit of detail. Some of the benefits of RC3 from our point of view is that it will work with existing web applications architecture. You do have to modify the application, but nothing new needs to be invented in the web applications. Just like the client server separated the GUI, the front end, and the back end, RC3 requires you to separate your data, classify your data in certain ways, and then build a transaction using the classification model. You only secure what's important. Things that are irrelevant don't need the same industrial strength security that things like credit card numbers or social security numbers need. The best part, you can prove to an auditor that you are in full control of the sensitive data and the cryptographic key management that protects that data. And of course, all of the benefits for leveraging the cloud. So what are the requirements for RC3? You have to classify your data first. If you don't classify your data, then you cannot take advantage of the architecture. But once you've classified it, you have bounded your problem. You now know what the problem is. Class 1 is considered regulated data, at least by our definition. You can call it anything you want. But